purpose of this week's lesson is going to be to revisit how we looked at energy. If you think back, we talked about how for any system, energy is conserved, as long as you're not taking any energy out or putting any energy in. Let's review some of the work we did back then.
So I think a good way to get ourselves back in that mindset is to look back at our energy posters, where we each took some sort of object and we showed how the energy going into it, or the original energy, is the same as the energy coming out of it, or the final energy. So we did EO equals EF. So in the case of my cat here, she takes in chemical energy through her food, and that energy is transformed into heat and occasionally kinetic energy when she decides to move. So all of you guys did some sort of poster like that, and we really emphasized the idea that energy doesn't go anywhere. It just gets switched from one form to another.
Now, it gets more complicated if your object isn't isolated. In other words, if things can add energy in or take energy away. The purpose of this week's lesson is going to be to talk about something called work, which is a way we can either put energy into the system or take energy out of a system.
I think this picture does a good job of explaining why we need the concept of work. This is one of the stranger things I ever saw. It's a side road in Oklahoma, and this car appears to have hit a tree in 1960, and they just left it there. So that's what things look like when you let them sit for 50 years in the woods. But if we think about the collision this thing had, it really shows why EO equals EF starts to get a little more complicated if you're looking at a single object. So let's try to write it for just the car. And we're not going to worry about the world. We're not going to say sound or heat or anything like that. We're just going to look at the car. What kind of energy did it have originally? Well, it had kinetic. It was traveling. How about at the end? Well, it's not moving, so it doesn't have kinetic. It doesn't have potential because the energy hasn't been stored. It's not like a spring or it hasn't been moved up high or anything like that. If we start to go through our list of types of energy, at the end, the car doesn't have any energy. So where did the energy go? It obviously left the car because the tree did work on the car. So work is a way you can add energy into a system or take energy out of a system. We're going to see in this lesson that it's pretty easy to calculate work. It involves having a force and having that force act over a certain distance. So in the case of this car, the tree was putting a force on it during the 3 or 4 feet it took for the car to come to a complete stop. And we can sort of see that based on how much the hood is crumpled. So we'll see during this lesson that to do work, to take someone's energy away, you have to have a force, and that force has to act for a certain distance.
For this unit, there's a really cool set of videos that was made in Canada in the early 1980s. And I hope you guys enjoy them because we found them to be pretty effective at a lot of different levels of high school physics. They're a little strange. It's almost like the animators from Sesame Street decided to get together and teach high school physics, but they're really good. And we hope you enjoy them and that you find them kind of funny.